Hi everyone, I'm Lauren Malhoit. I work for Cisco in the NCMA BU. I've been there for about 6 weeks, so this is my first ACI presentation for them. But feel free to ask me questions. I'm going to do about 10 slides, and then we'll get into our rigged up whiteboarding here. So with that, you can see my Twitter handle and my email address. If we don't have time for questions or if I can't answer them for you, because I'm pretty new still, feel free to contact me either of those ways. All right, so to begin with, so why do we need to change our data center, and what do we need to do to catch networking up with the rest of the data center, essentially? We have things like SSD and all-flash arrays now. We have things like UCS or any kind of blade servers. It lets us get data in and out of servers at such a fast rate that we really need to start going to 10 and 40 gig infrastructures. We get VM density. You know, there it says it's something like 11, average 11 VMs per host. I've seen way more than that and done way more than that, of course. So that seems a little low to me, actually. And then we have things like big data and SAP and all sorts of applications that require a ton of data and really increase that east to west traffic. And I'm sure you guys have heard this, that traditionally, you know, we've had the north-south bound traffic. That's been kind of what we've been working with and designing our networks for the last 20 years. But now, really, we're designing for east-west traffic at this point. So with that, you know, our compute, we do refresh cycles every 3 to 5 years. With our storage, even 3 to 5 years, we're replacing giant storage arrays, even switching to scale-out architecture and things like that. But our networking has, again, stayed the same, and people aren't refreshing their networks, their network devices at the same rate. You know, people might have the same network devices for 10 years, and that's normal to them. So we need to start with the networking. We need to keep up with the rest of the data center, essentially. So another problem that ACI solves with the other SDN providers aren't really looking at is the language barriers between the application teams and the network teams. So where an application team is actually talking about security requirements and performance, the network team needs to know about VLANs, and they need to know about IP address schemas, where the firewall should go, things like that. And that language barrier is actually preventing them from talking to each other. And they don't want to talk to each other. I don't know if you've ever been in the room with a network owner and an application owner, and they hate each other, essentially, because they're speaking a different language. That's really keeping them from, you know, going to market faster, having applications that perform well and perform efficiently, and really, you know, let us provision quickly. So with ACI, we start with a few building blocks. And as you can see there, we have our Nexus 9000 series switches. And you know, this is a little bit of a marking slide, but we have our 5 Ps, our price, performance, port density, programmability, and power efficiency. What I'm really going to concentrate on here, what you guys probably care about, is the programmability that comes along with the Nexus 9000 series switches. So with other switches, even in the Cisco family, we don't have an API that covers everything. But with the 9000 series switches, the API covers it all. Whether we want to come in through the CLI or the GUI or use a custom script or any kind of custom cloud orchestration tool, we can go through the open APIs of the Nexus 9000 and do everything that we need to do with it. So let's talk about the other building blocks of ACI. The APIC, the Application Policy Infrastructure Controller, is kind of the brains and the heart of the operation. It's, you know, like with other SDN solutions, we need a controller, and that's what makes it software defined. The APIC also has an open API, which we'll get into in a second. And then we have a policy model, which is really what kind of sets ACI apart. It gets us into that promise theory, if you've ever heard of that, the declarative versus the imperative model. Now, the imperative model is what we've been using traditionally in our networks for the last 20 years. We have a switch, and as a network admin, we SSH into that switch. We enable a port. We put it in access mode. We give it a VLAN, VLAN 10, whatever. We're doing specific instruction sets, and as a network admin, we need to know the specific instruction sets for each model of switch, each model of firewall, each layer 2 through 7 network device, essentially. And that's imperative control, because we need to know each instruction set. Now, with a declarative model, we are actually using policies. We want a desired state, and we want to make sure that our current state matches that desired state at any given time. So we use the policy model in ACI, and through the APIC, we can configure these policies and say, hey, we want this group of servers or this application to be able to communicate with this application. And we do that in sort of a common language. And we can do that unidirectionally or bidirectionally. And all we need to know is how to configure the APIC. We don't need to know each instruction set for each model for every vendor out there. And we can work with multiple vendors, different layer 2 through 7 devices. All right, so let's talk a little bit about the APIC, because that's really what makes it ACI, right? So there are basically 4 functions. And we have, like I said, an open API where we can use scripting, we can use custom GUIs, we can use the GUI that comes with the APIC. Anything you can imagine, cloud orchestration tools, we can use those with the APIC, because again, it is an open API. We also get visibility info into both our physical and our virtual networks. Everything's through a single management device, which is, again, the APIC. We can get, in the future, application information also, health scores, latency, all sorts of things that other SDN solutions can't really give us yet, especially for the hardware. We also get reliability. So we need at least 3 APICs in each production environment, and that gives us kind of that reliability. If one goes down, we still have 2 others. And we actually do this through sharding. It's a replication through sharding. Everyone wants to laugh when we say that, of course. But basically, we have one shard that goes across 3 APICs. And of course, we can have more APICs depending on the size of our network, but that's our starting, the minimum. If you have like a dev environment, you could probably use 1 APIC, get away with it if you don't care if it goes down, et cetera. And like I said, we could have more than 3 APICs. We get that scalability. We can add on to our leafs and spines, which I'll get into as well, to scale ACI out the way we need to for our environment. This is kind of a little bit of a marketing slide, but basically just so you're aware, third-party analysts have said that Cisco has the fastest 10 and 40 gig switches out there. And also, we are the most power efficient for our class of switches. I won't spend a ton of time on that slide. But everyone's concerned with ACI, and I have to buy Nexus 9000 switches, and yeah, I mean that's a valid concern, of course. Budgeting is something that we all have to worry about. But like I said, our refresh cycles are shrinking within the network now. So here's kind of how we transition from our traditional networking to an ACI fabric. So we start out with traditional networking, 2 or 3 tier design. We have our core aggregation access layer, which we're all kind of familiar with. As we start cycling in Nexus 9000 series switches, we still get, we have that traditional networking design that we're used to, but we get that programmability that comes with Nexus Series 9000. We also get a modernized OS with the NX OS. So then we move into kind of the layer 3 overlay, which is that second picture there. And with this, we get the penalty-free, non-blocking VXLAN overlay. So we don't have layer 2 issues like STP convergence, essentially, that can cause latency within our network. We also have only 2 hops from every end device to the next end device. It goes to a spine switch and then a leaf switch. The spine being the top layer there, the leaf switch being the bottom layer. And then, of course, our end devices at the bottom. And it can be any end device, of course, and it can handle NVGRE encapsulation, VLAN encapsulation, VXLAN encapsulation. So we can use OpenFlow support if we want to. We can put in other SDN controllers in that model if we want, and centralize that management if we need to. Now, that is what's missing, though, is we add our own centralized management. So the third picture there actually shows ACI, and it's a lot like the second picture, except we've added APICs at this point. So we get that centralized management, we get that application visibility, the hardware or the physical and virtual layers of visibility, the open APIs. Oh no, and my whiteboard's falling. So that's kind of what comes along with. That's how we transition from the traditional model to the ACI model. And this slide just kind of shows that we have app mobility. I can switch from a private cloud to a public cloud to the hybrid cloud and whatever I want. And we're really concentrating on the applications. We don't care about the VMs. We don't care about the containers. It doesn't matter to us. We just want to make sure that we provide the best application performance and putting them where they need to go. We also get app visibility, like I said, and you can see health scores, telemetry, latency, isolation, things like that. Here is basically, so ACI doesn't provision VMs, right? It is a networking virtualization as well as hardware abstraction tool. It doesn't do VM lifecycle management. So we can put Cisco UCS Director or VMware VCAC, OpenStack, CloudStack at the top and use them as cloud orchestration tools to manage our whole software-defined data center and really get that whole picture there. And Cisco ACI will work with any of those tools. And multi-tenancy, we all kind of know what that is, but I just want to make sure you're all aware that we can do multi-tenancy within ACI. If you want to dev, tenant, prod, tenant, Coke, Pepsi, however you want to divide up your organization, engineering, sales, what have you. I'm sure we're all kind of familiar with multi-tenancy, so I'm not going to spend a ton of time on that. So that's kind of my slideshow there. So let's kind of look at ACI and what it is. As you saw in that picture, we have 2 spine leafs, or we can have any amount of spine leafs, actually. But we have our spine leafs on top, which are generally Nexus 9500 switches, maybe a Nexus 9508 with an ACI-enabled ASIC line card within it. And then each leaf switch is connected to both spines. The spines can't be connected to each other. The leaf switches can't be connected to each other. So it all goes through this. It all goes through a spine, and the spine is what keeps that database of where the end devices are. And this is actually called a Klaus fabric, or more familiarly, spine and leaf architecture. And then again, we have our APICs coming off of it. And we'll have at least 3, as I said. So that's basically ACI in a nutshell. So now we have host devices coming off of all of these switches, all of these leaf switches, right? And as you can see, like I said, we have 2 hops, one to the spine, one to the next leaf, wherever that host lives. But we also have application or VM mobility, things like that. So let's say this is host 1, this is host 2, and this could be virtual or physical host, we don't care. And host 2 decides to move over here, which is totally possible with vMotion, things like that. So now, and Lillian Kwan does a way better job of explaining this because she's brilliant, but check out her YouTube video. It is amazing, just on ACI traffic flows. I highly recommend it. So spine 1 still thinks host 2 is here, so it's going to go here. It's going to get a bounce, and then it's going to bounce here. And host 2 is going to advertise through gratuitous ARP that it's now on leaf 3, and now host 1 will still have 2 hops to get to host 2. So that's essentially how the traffic flows work within ACI. And again, that's all VXLAN in the middle, and we can handle any encapsulation that you want. So that's kind of the networking, the hardware part of it. But let's talk about policies, because that's really what's interesting about ACI. So we have what are called endpoint groups, or EPGs, if you will. Endpoint groups can be just groups or containers of any sorts of host devices, and we can divide those up either manually, we can do it by virtual port group. Usually it's going to have hosts that are similar, like the 3-tier application, right? So we have a web endpoint group, an application endpoint group, and a database endpoint group, right? We're all familiar with that 3-tier application. It can be more tiers, we don't care. And somehow we want to connect these. And we're going to connect them in different ways. We're going to connect them using, unidirectional or bidirectional things, but we want policies here, right? And in ACI, we call them contracts. Now, a contract will be made up of a filter, an action, and an optional label. You don't have to have the label, but the filter is basically going to be like TCP port 80. The action is going to be permit or deny, and the label might be web access. It's kind of arbitrary. It's like tagging, essentially. So each contract is going to have at least 2 of 3 of those, if not all 3. And these right here can be unidirectional or bidirectional. So maybe I only want the web to provide this contract and the application EPG to consume it. Again, it's a provision and consumption model based on promise theory, which I recommend, breezing through. You don't have to understand exactly what promise theory is, but there are books, white papers out there. Unlike ACLs, we can do bidirectional just by clicking on something and saying we want this to be both a provider and a consumer of that contract. Now, the neat thing here is that this whole thing is called an application network profile, right? So those things are copyable. I can repeat this process for anything that I want. So if I have a dev tenant and a prod tenant, and I have AMP1 over here, we probably wouldn't call it that, but let's just say we do. I can have my developers, work on it. I can have my QA testers QA it. I can do all sorts of things in here. And when I'm ready, I can go ahead and copy that right over here in about 5 minutes. So it becomes a repeatable process. And there's no human error. We're not repeating it through humans copying it, right? So we have change management built in. We have faster go-to-market times, all of that good stuff. So now we have also stateless inspection, right? So we can block traffic if we need to. We don't have the deep packet inspection with the policies, but we can block traffic. Now, Gelsinger yesterday was talking about how firewalls are generally on the outside of everything, and it's hard to do microsegmentation in a physical world because it's just too expensive, and the administration fee is actually just kind of outlandish. So we don't necessarily put firewalls everywhere they need to be. Now we can, of course, because in ACI we have what are called service graphs, and I can put any layer 4 through 7 device in a service graph. So let's say I have a firewall, load balancer, whatever other layer 4 through 7 device that you want. I can build a service graph with that and put that deep packet inspection anywhere. Now, that's not going to be 2 separate paths. That's just kind of how I'm showing it. But so I can get deep packet inspection, and I can get load balancing from my web EPG to my app EPG. And again, that is a repeatable process. I can copy that and put it somewhere else, either in a different tenant or between 2 other EPGs. And within 5 minutes, I have that exact same service graph somewhere else. Now, the way we're doing this currently is through device packages. Device packages are created by the vendor. So Cisco might create a Cisco ACI device package, and we'd upload that through the APIC. And then the device package holds all the features that are configurable for that particular device. It might be F5 load balancers, what have you. But in the future, and this is what's cool, we'll have the OpFlex protocol. So this is really one of the only southbound protocols we can use for getting device information. And Cisco is just one of the vendors developing this. We're developing it with many other vendors, including F5. And it's currently at the IETF for approval. So again, it's an open protocol that any vendor can use. And what we're going to do is we're going to have a firewall, let's say, with an OpFlex agent on it. And then we're going to have an OpFlex controller up here. Let's say it's an APIC because we're talking about ACI. This OpFlex agent will advertise the features of whatever that layer 4 through 7 device is and tell the APIC what it can do. And then again, we can configure policies declaratively through that APIC. And then when that firewall gets a firmware upgrade, we can advertise that through the OpFlex agent. And it's a seamless upgrade, essentially. And we can keep doing that declarative model as it's meant to be in an easier way. And again, more vendors, because of customer demand, will get involved with this OpFlex protocol. So that's kind of ACI in a nutshell. I probably kind of went through it kind of fast. And again, it's a high-level description of it. But do you guys have any questions? So those are APICs. Yes. Yes. OK, so the APIC right now is a Cisco UCS C-Series 220 M3. And it comes as a hardened image on the UCS rack mount server. If you're not familiar with UCS, the C-Series is a rack mount server. I believe the 220s are like 1U. So right now, that is what it is. It's a hardened image. And it's not something you can't like manage it through UCS Manager or anything like that. It's a different image completely, a hardened secure image that we sell with the ACI. So the 9K switches, I would usually put 7Ks in. I'm not buying my 7Ks. Yeah, that's the question that everyone asks, right? What are we doing about 7Ks? And I honestly don't know. I'm sorry? And I believe the 5Ks are being rolled into the ACI infrastructure, and I can get you more information on that if you send me an email. But the 7Ks, I don't honestly know about. I mean, even if I'm not even lying to you, I've been there for 6 weeks, so I don't really know for sure. But yeah, feel free to send me an email, and I'd be glad to answer those questions for you. But to sort of answer the question, and there is a white paper out there about transitioning from current to ACI, and you can, I mean, so the 7Ks won't be technically in your ACI infrastructure, but you can do things with putting like the spines over here and including your current network. So basically you're just extending into a new pod with ACI as you transition into, you know, full ACI, full-blown ACI, which is probably not something I should say. Yeah, so that's basically where we are with that's basically where we are with the transitioning from other Nexus gear. And there are white papers out there currently on that, and videos too, actually. So I can definitely get those to you. Any other questions?
The Apex, is there any high availability there, or like how does that look?
So it's through the sharding. You can basically each APIC will have its own IP address. You can browse to each IP. It doesn't matter, but it's all the same. And through the sharding, it does that replication. So as you know, if you lose 2, you're okay. If you lose 3, you're not great. But you know, if you have 6 or 5, or I think actually you have to have odd numbers right now. You know, the more APICs you have, the more reliability you have. But that'll be based on your network as well. You don't need to have a crazy amount if you don't have a huge network. Anyone else? You guys are being too easy on me. I've actually been able to answer some of these questions. All right. Well, very good. Thank you so much for watching, and seriously, contact me anytime. I'm available. Thank you.